Hey guys, welcome to another video. Today's learning objective is all about collecting like terms. As usual, feel free to skip to any part of the video. I won't be offended, timestamps are here. So before we get started on this learning objective, it's quite important to check out the videos that I've already done, the last two videos on algebra. They will be kind of really helpful for what's going on here. And you know, if you want to see if you remember them properly or not, just ask yourself the quick question. For example, do you know what, say, 5y equals, for example, and do you know why that's the same as 5 times y? And do you know, for example, what x cubed, for example, means? And do you know why that's, x times x times x? So if you kind of remember those things, you're probably alright to check out this video. So let me just get rid of these. Okay, so let me give you an example first. So say you've got, two Drakes. Here's Drake, and then you add another, say, 3 Drakes to that. How many Drakes are you left with? Well, this seems, that's a pretty obvious question, right? That's the same thing as saying 2 Drakes is the same thing as saying, 1 Drake plus another Drake. And then 3 Drakes is the same thing as saying, Drake plus Drake plus Drake. And since there's a little plus sign here as well, which is this plus, that just becomes 5 Drakes, right? There we are, and kind of I can write that here as well, 5 Drakes. And kind of what we're really doing here is we're collecting like terms. Because this Drake is the same as, this Drake is actually the same as this Drake, we can add them up. And so if we kind of draw this to algebra, for example, what's 2x plus 5x? Well, again, if we want to break it down simply, that's 2x is x plus x, and then we add, and then 5x, for example, is x plus, oh god, I should not have picked 5x, x plus x plus x plus x plus x. That's 5, right? Which is then, of course, 7x, right? So in that way, that's all kind of collecting like terms is. Since we know that this x is the same as this x, we can add them up. But say, for example, if we were to add kind of, say if the equation we changed this initial equation, instead of, adding 2 plus 3 Drakes, say we had, we were to add, say, 2 bananas. So 2 banana, that's a very badly drawn banana, 2 bananas, and then we'll also add in 4 bananas here. I hope you guys can see that. I know it's yellow. So that we know we can add the 4 bananas to 2 bananas, right? We can add this to this, which becomes plus 6 bananas, right? But we can't add the bananas to the Drakes because kind of they're different things, right? But Drake is not the same thing as banana. The song claim his music is like that. I mean, I definitely disagree. Quite like Drake. But yeah, so in that same regard, say if we had, instead of x, we had, say, 2y plus 4y here. By the same logic we used before, we know we can add the y's, right? Because they're the same thing, they're like terms. Plus 6y. But since the y's and the x's are different, we can't add those together. So that's why we can collect like terms, but if applied to a more kind of, if we have different terms, we can't apply them together, add them together. So that's really kind of the key takeaway, and that's all the theory there is. You can add the things that are the same, but you can't add things that are different, which kind of isn't as complex as you might think, but it's kind of a very important building block into more advanced algebra. So let's try a question for this. This is to simplify minus 6k plus 6k minus k. Why don't you pause the video for a second and see how this might work? This is very similar to our kind of initial, 2 Drake plus 3 Drake example. Okay, did you give the video a pause? Okay, perfect. Minus 6k plus 6k minus k. So minus 6k plus 6k minus k. Well, minus 6 plus 6k is 0, and then minus k again is just minus k, right? If we're adding the like terms. And kind of that's all there is to it. Okay, let's move on to a bit more of a complicated example. This is to simplify, I'm not going to read that out, 7g cubed plus 6g cubed minus 3dm squared minus 5g cubed. Okay, well, it looks a bit more complicated, but this is actually just the same thing as our kind of second example with drakes and bananas. There's two different terms here. There are the g cubed terms and this dm squared term. Okay, well, we can do 7g cubed plus 6g cubed minus 5g cubed, which is 7 plus 6 minus 5, which is just 8g cubed. Oh, wrong color. Let me switch back to, there we go, which is 7, so what did I say, 8g cubed, and then minus 3dm squared. And that's kind of all there is to it. Let me actually give you another example as well, where kind of a common mistake that students sometimes make will come up. So say we have the question of, let me do this in purple, say 5x squared plus 5x plus 7x minus 2x squared. Take the video, take a few minutes, pause the video, and see what this might equal to. Okay. Remember, we can only add like terms. And the thing is, for example, x squared is actually different to x, because x squared, of course, is x times x, whereas x is just, just x. So we actually can't add the x squares to the x cubed. They're not the same term. So in this case, we do 5x squared minus 2x squared, which is 3x squared. Oh, wrong color as usual. 3x squared, and then we can do the 5x plus 7x, which is 12x. So that's really important here, not to make the mistake of kind of, because there's an x squared here and there's an x there, they might seem similar, but it's important not to confuse them. I'll do another one as well with another common mistake students sometimes make. So say we have, back to purple, 7yx plus 8xy plus 4x squared plus 5y squared. Okay. Again, why don't you pause the video for a second and see what might happen. Okay, so the first thing we notice is that, for example, the x squared term, there's no other x squared term. And the same thing with the y squared term. So, let me actually change colors for that, so the y squared term. So we can do 5y squared plus 4x squared. There's no other like terms for these that can be added. But now here, this 8xy and 7yx, that's actually a bit cheeky right there, what the question's done. Because if we remember, for example, 7yx is the same thing, or actually yx just means y times x. But y times x is the same thing as saying x times y, right? Because say, for example, if we had 5 times 2, that's 10, which is the same thing as 2 times 5. So in multiplication, it doesn't matter which one goes first, right? And since x times y is xy, these two are actually like terms, but they kind of looks a bit different. So that's something that might catch you out sometimes. So yx is the same thing as xy, these are like terms, and hence can be added. So 7 plus 8, 15, and you can write this as yx or xy. Remember, we said the same thing. So I'm just going to write xy because, I like to do it in alphabetical order. That's just kind of what some people like doing, it's just random preference. It doesn't really matter. But this is kind of a bit of a trick that sometimes people try to catch you out with. So it's really important not to get fazed by this. So it's been a bit of a longer video again, and there's been we covered the main concept of adding like terms, or collecting like terms rather. So this is the main thing you need to remember. If they're like, you can add them or you can subtract them. But if they're not kind of the same, then you can't add or subtract. You cannot collect them. So kind of just keep that in mind whenever you see questions like these. Again, if this is a new concept, really important to practice to make sure it gets drilled into you and it becomes a bit more second nature. But hope that kind of video helped, and see you guys in the next one.